Good morning, class. Today we're going to look at some more exercises from chapter 2, and we will begin with exercise 2.5. So if you'll bear with me just a minute, I'm going to open up and share my Excel spreadsheet with you today. And let me see, I know this is not the right one, so let's see if I can share with you the correct one. All right, you should be able to see Cornerstone exercise 2.5 now. In Cornerstone exercise 2.5, we're going to be reviewing a little bit about your prime cost and how to find prime cost per unit. We're going to be looking at conversion cost and conversion cost per unit. And then we are going to determine variable cost and variable cost per unit, as well as the total cost per unit for this particular exercise. In this exercise, that's different than what we've been talking about, is we're going to be doing a service type of business instead of actually producing products for a company. So it's always important for you to read your instructions to your exercises, because they have some important information in them for you that will help you in solving the answers to these problems. Jean and Tom Peretz own and manage Happy Home Helpers. It's a house cleaning service. Each cleaning one house one time, takes a team of 3 house cleaners about 1.5 hours. On average, the Happy Home Helpers completes about 15,000 cleanings per year. The following costs are associated with the total cleanings. And so I've put out here on a spreadsheet that there are going to be 15,000 cleanings. We're going to need that when we are solving for the answers to this problem. They have given us the direct materials cost, direct labor cost, and they've split the overhead down into variable overhead and fixed overhead. So in the first requirement, what they want you to do is they want you to calculate the prime cost per cleaning. You have to find the total prime cost first, and the prime costs are going to be equal to your direct materials plus your direct labor. Once you know the total of the prime cost, divide them by the number of cleanings, which was 15,000 for this company, and that will give you the prime cost per cleaning. So again, you're going to take the direct materials and the direct labor, add them together, and divide it by the number of cleanings per year, and that's how you come up with the prime cost per cleaning. And so they're just looking at the cost here. Make sure you have your calculator set on rounding rules. In this case, it went out to 33.3, and if you used dollar amounts for this, it'd be $33.30. In part 2, they want you to calculate the conversion cost per cleaning. Your conversion cost per cleaning, first of all, you would need to find the conversion cost. And conversion cost, the total of the conversion costs are found by adding your direct labor and your total overhead together. So my direct labor amount of $47,000 or $472,500 plus my variable overhead and my fixed overhead, all of those combined would be the total conversion cost. Once you have the total conversion cost, you're going to divide by the number of cleanings, and that will give you the conversion cost per unit. In part 3, they want you to calculate the total variable cost per cleaning. So in this case, you need to remember that direct materials is considered to be a variable cost. Direct materials cost would vary with the number of cleanings. Direct labor is a variable cost too. Direct labor is associated with the number of cleanings also, and that's why it makes it a variable cost. Your variable overhead, they lump together your cleaning overhead that would be affected by the number of cleanings. So variable overhead in this case is $15,000. You would combine your direct materials, your direct labor, and your variable overhead together to get the total variable cost. And we would divide that by the number of cleanings, which again is 15,000. The variable cost per cleaning then is $34.30. Again, it's the sum of your materials, your labor, and your variable overhead, all of that combined together to get your total variable cost divided by 15,000, the number of cleanings that you have completed for this company. In number 4, they want you to calculate the total service cost per cleaning. That means they want you to combine all of the costs together, and once you've done that, divide it by 15,000 cleanings, and that will give you a cost of $35.50. In the last part of this exercise, they give you a what-if analysis. What if the rent on the office that Jean and Tom used to run HHH increased by $1,500? Which of the following statements best describes the effect on HHH cost? Would fixed overhead cost would increase, therefore the conversion cost would increase, and the per unit cost would increase. I've proved that by putting it back through the formulas that we used to calculate the total cost and the cost per unit. Remember, your direct materials was $27,000. Your direct labor was $472,500. Both of those were given. Your variable factory overhead would have remained the same at $15,000, but your fixed factory overhead would have changed because rent is considered to be a fixed cost. It will add to the costs that are already considered to be fixed cost. So our fixed overhead costs were $18,000 before the what-if analysis. But when we apply that $1,500 to that, the total fixed cost would have increased to $19,500. Therefore, the total cost, all of these combined, the materials, labor, and all of the overhead combined together, would amount to $534,000. The total fixed cost would make the total cost change or go up. So therefore, your cost per unit will also go up. The cost per unit now is $35.60, whereas before it was $35.50. Again, we would take this total cost of $534,000 and divide it by 15,000 cleanings, and that's how you would get $35.60. So the cost per unit has increased. The fixed overhead cost would increase if the rent increased. The conversion cost would increase, and the per unit cost would also increase. Remember, conversion cost were your direct labor and all of your factory overhead combined. So your total conversion cost would have increased. And so that would make the per unit cost increase too. On this side, I've calculated the per unit cost of each one of the materials, labor, and the overhead costs separately. Also out to the side, I've given you a little note here that says when the total fixed costs go up and the number of units stay the same, or the number of cleanings in this case stays the same, the fixed cost per unit will increase. And so if you did each one of these costs separately, we would have taken each one of the costs and divided it by 15,000 cleanings. That's how I got each one of these separate. If you were to combine all of these together, the total cost is $35.60. So there's lots of different ways that you can calculate the cost per unit. But in this case, I've given you two separate ways so that you could see either way. You could do it per unit, on a per unit basis, and combine all of these together to get the total unit cost, or you could just take the total cost and divide it by 15,000, and that will give you 35.60. But the whole purpose of the what if analysis is to get you thinking about how changes in cost will affect the cost per unit. And the key here is that you needed to know that rent is considered to be a fixed cost. So it made my fixed cost go up, which would make the total cost go up, which means that the total cost per unit would increase if the number of units stays the same. So they're trying to remind you a little bit about cost behavior and how costs affect the unit cost, the per unit cost. And so that's all there is to this first exercise. So if you'll bear with me just a minute, I'm going to bring up our next exercise, which is exercise 2.6. So now you should be able to see exercise 2.6. It's really a continuation of exercise 2.5. And these are cornerstone exercises if you're following along with them in your textbook. The same owners, it's the same company, and it's the same amount of time and cleaners that they have available. They still are completing about 5,000 cleanings per year. These are your materials called your labor, your variable overhead, and your fixed overhead. you have to find the materials cost in this particular problem. Now, what we're doing is we're preparing a statement of cost of services produced. This would be the equivalent of a statement of manufacturing cost for a manufacturing business. This is not a manufacturing business. It is a service business, but it operates basically the same way for the financial statements that you have to produce. There's just some changes in the name or the title of the statement itself. So instead of doing a statement of cost of goods manufactured, we're going to be doing a statement of cost of services produced, because this business is a service type of business. They are not manufacturing a product. It starts out basically the same. You're going to have some direct materials that you will be using in your service business. The direct materials have a beginning inventory of $4,000. That was given in the problem. The direct materials beginning inventory is $4,000. So we're going to start with direct materials beginning inventory. To that, we're going to add the cost of the purchases of the materials. The purchases of the materials was given at $25,600. Then you're going to simply combine the beginning inventory and the cost of the purchases together to get the materials that you have available to provide for your services of this company. The ending materials was given at $2,600. The direct materials ending inventory is $2,600, so I just plug that into the statement. The direct materials used in the production of the services is the same, calculated the same as it is with a manufacturing business that produces products. So beginning inventory plus purchases tells you what materials you have available to sell minus what you had left over in ending inventory. That tells you how many materials you used this period of time. To that, we're going to add our direct labor. Our direct labor was also given at $472,500. Notice that our factory overhead name changes to service overhead, but it's still the overhead cost of running a service business would be calculated next. And so we need to look at the services. We had variable services overhead of $15,000. We have fixed services overhead of $18,000. If you combine both of the services overhead together, it will give you this total at $33,000. In a service business, your total services will be the materials that you've used, the labor, and the services overhead combined. In this particular problem, they had no beginning work in process inventory. In other words, they completed all of their services. There was no beginning work in process last period that would have come from ending work in process. There was none of that. In this period, they completed all of their services, so there was no ending work in process. So if there's no beginning or ending work in services, then the total service production cost will be equal to the cost of the services produced. This cost of services produced would be fed into the cost of goods sold section of your income statement for a service business. We're going to see that in the next exercise. So you have to keep in mind what the total cost of the services produced is, because this amount is going to feed directly into the cost of goods sold in the next part. As always, they give you a little what if analysis to test you to see if you know or understand the concepts that are going on. In this part 2, the what if analysis, it says, what if HHH company planned to purchase 30,000 of direct materials? Assume there would be no change in beginning or ending inventories of materials. What effect would this have on the cost of services produced? And the answer to that is the direct materials used in production would go up. It would go up by the difference between 30,000 and the materials, which was the materials purchases of 25,600. The difference between 30,000 and 25,600 would be the amount that the cost would go up. And so that's all that they wanted you to do on this exercise. So now I'm going to move to the next exercise, which is connected to this same problem, and we're going to produce a cost of services sold. And so if you'll bear with me just a second as I pull up exercise 7. And I've copied that in for you. Basically, it's the same company. The same amount of materials are going to be purchased. The same beginning and ending inventories. They're just telling you this additional information here, that there is no work in process inventory and no finished goods inventory. In other words, a cleaning is started and completed on the same day. Now, this cost of services sold is going to look a little strange to you, because what we're starting with is the cost of services produced that we picked up from the previous exercise. We calculated this amount just a few minutes ago from the previous exercise. Now, normally, if you were doing a manufacturing business and you were producing products, you would take the cost of goods manufactured and add the beginning finished goods inventory to that. Since we're talking about a service business, there is no finished goods inventory in a service business. And the reason for that is a service cannot be stored. So the cost of the services produced that we've already calculated from the previous exercise will be equal to the cost of services that would be available for sale and the cost of the services sold. And the reason for that is because there's no beginning or ending finished goods inventory that we would calculate in the services sold. So technically, I don't even think there was a reason for you to produce a statement of cost of services sold. You would just feed the amount of the services produced into the income statement that I'll show you in the next exercise. So if you'll bear with me, I'll bring up the next exercise with you, and you should be able to see Cornerstone exercise 2.8 now. And in this exercise, they want us to prepare an income statement. All of the information is the same, but they've added this additional piece of information so you would know how to calculate your sales and you would know what your administrative and selling expenses are. Notice it says there's no work in process inventory because they specifically stated in this problem that they didn't have any services that were not complete at the end of the last period or the end of this period. So there was no work in process inventory, but there could have been a work in process inventory of services. For example, if you are a law firm and you are handling a case, it might take you several months to work on that particular case to provide that service for the customer. You might start that service in 1 month and not finish it for several months. And so you could have some work in process for services, but that was not the case in this problem because they specifically told you that. But you will never have any finished goods inventory because services are not finished products. You can't store a service. A service is intangible. It doesn't have any physical properties associated with it. And so when we are working with a service type of business, there can be work in process for services, but there will not be any finished goods for services at all. So for this income statement, we're going to calculate the sales. And they were expected to sell 15,000 cleanings at a price of $45 each. So you're going to multiply the number of cleanings that you sold times the cleaning price, and that will give you $675,000. You're going to subtract out the cost of services sold, which was from Cornerstone exercise 2.7. That's what we came up with a few minutes ago. And the difference between the cost of services sold and the sales is the gross margin. Notice that the terminology here, instead of it saying cost of goods sold, is talking about services because we are a service business. The gross margin or gross profit is calculated exactly the same way. We would subtract our cost of services from our sales to get our gross margin. Then we would deduct out any operating expenses, which will consist of selling expenses of $22,000 that they gave you, and administrative expenses of $53,000, which was given. The total of your selling expenses and administrative expenses gives you total operating expenses of $75,000. These would be deducted from your gross margin to leave you with the operating income. So this is the income statement for a services type of business. Just your terminology has changed. It amounts to basically the same thing that we've been doing. There's also a what if analysis with this problem. What if Jean and Tom increased the price to $50 per cleaning, so no other information was affected? Which of the following statements would be true? Would sales rise by 50,000? Or would operating income rise by 142,500? Or would fixed cost per cleaning, would it decrease? The best answer is operating income would rise to 142,500 because your selling price increased, your total sales would have increased. It actually increased from $45 to $50, so there'd be a $5 difference per unit sold. And therefore the operating income would increase by this difference, and the operating income would rise to 142,500. If you changed your sales, your gross margin would change and your operating income would change. Everything else stays the same. So the correct answer is that the operating income would rise to 142,500. So the whole purpose of this is to show you what would happen to a service type of business. What would happen in their financial statements? How would they be different from a regular manufacturing company that was producing products sold? And so I just wanted to show you what would happen if we were producing a service instead of a product. In the next example that we're going to go through, I'm going to have to go back to Cengage for that. I don't have an Excel spreadsheet with it. So if you'll just bear with me for a minute. I'm going to see if I can go to a new share, and I'm going to see if I can pull up my problems, and I have. We're going to look at exercise 2.09 this time. And it's a little bit different from the other exercises that we've talked about today. This one has to do with systems concepts, which is something that they mentioned in the first couple of objectives in your chapter. They talked about systems, they talked about different accounting systems and what goes into the parts of a system. So this is just giving you some practice on learning the different terminology that's associated with systems concepts, and it's giving you kind of a think through problem that you're going to be working here. First of all, it's very important that you read all of your instructions here so you'll know what's going on within the problem. And first of all, in general, it says systems are described by the following pattern. All systems have some type of interrelated parts associated with them. In a system, we're going to have these parts that will help us to process the information. And once the information is processed, we can come out with an output, which will be our objective for this particular problem that we're working on. So like in an accounting system, we're going to put in our economic data in the form of transactions. We're going to put them through processes where we summarize that information, and then we will report that information. And eventually we're doing all of this because we want to make sure that management can make good decisions, or really any user of accounting information could use the information that we've reported to make good decisions. So in an accounting information system, the objective would be to report information that would be meaningful to the users of that accounting information. And the objective of that is that the users would be able to make good decisions about the company, whether to invest in the company, or even whether to work in the company. Now, this is not going to be talking about an accounting system. This is just a total what if analysis here. But it's very important that you read this part so you'll understand what we're trying to do in this particular problem. The dishwashing system of a college cafeteria consists of the following steps. The first step is first, students will dispose of any waste paper, napkins. They will dispose of it in a trash can. So if this is a college cafeteria, if you can imagine, when the students are finished with their food, they'll bring back their plates and their napkins and things on a tray. And the students will dispose of any paper in the trash can. And then they file by an opening system to the dishwashing area and drop off their trays. So in other words, this is a college cafeteria. The students are finished eating, they throw away their paper stuff, and then they drop off their trays in this cafeteria system that we're looking at. Persons number 1 and 2 are going to take the trays. These are persons that we've hired in our cafeteria system. They're going to take the trays. They're going to rinse the extra food down the disposal. They're going to stack the dishes and glasses and silverware in heavy-duty plastic racks. These racks will slide along a conveyor into the automatic dishwasher. When the racks emerge from the other end of the dishwasher, they will contain clean, germ-free items. 3 persons will remove the racks, and with the fourth person, they're going to empty the racks of the clean items. They're going to stack the dishes, silverware and glasses, and trays for a future use. The empty racks are then returned to the starting position in front of persons 1 and 2. The following items are associated with the dishwashing system. So these are the items that are associated with the dishwashing system. First of all, what they want you to determine is what is the overall objective of this dishwashing system. And they've given you a list to choose from. And if you are looking through this list, the clean, germ-free dishes and glasses and silverware are what we want to have as an objective of this dishwashing system. So the overall objective of this system, that's part number 3, is that we want clean dishes, clean, germ-free glasses and silverware. Clean dishes are our objective of the cafeteria. In the second part of this part 1 problem, they refer to scraping the uneaten food off the dishes into the disposal, loading the racks and washing the dishes, and unloading the racks would be considered these are the activities of the employees. And so these activities are considered processes. So the processes are the activities of loading the racks, washing the dishes, unloading the racks. The objective is clean dishes. In part 2, they want you to classify the items into one of the following categories. You need to be able to tell if it's an interrelated part, if it's an input, or it's an output. So we're going to start with A, which was the automatic dishwasher. And they've given you a list to choose from. The automatic dishwasher would be considered an interrelated part to getting the dishes clean. So of the categories, it's not necessarily considered an input or an output. Those would be the things that we would need to make the dishes clean. The output is the clean dishes, basically. So the interrelated part would be what is considered to be the automatic dishwasher. The racks to hold the dirty dishes, the silverware and the dishes. We're talking about the racks. The racks are also an interrelated part of this process. You need the racks to be able to hold the dirty glasses, silverware, and dishes so that you can put them into the automatic dishwasher, which is also an interrelated part. Now, before we can get the dishwasher to work, we have to put some electricity to the dishwasher, and that's going to be considered an input. Our water, before we can get the dishes washed, has to be put into the dishwasher. That too is an input. The waste disposal is considered to be an interrelated part. You don't need it to operate the dishwasher. You don't need it to hold the dirty glasses or the dishes together. But it should be an interrelated part. Sinks and sprayers, you're going to become a part of the dishwasher itself. So this is an interrelated part. And I'm checking each one of these as we go. The dish detergent is something that you have to input into the dishwasher to make the dishwasher run. So this would be considered an input. The gas heater to heat up the water to 180 degrees is an interrelated part. You have to have a heater to heat the water that goes into the automatic dishwasher. That's an interrelated part. The conveyor belt is also an interrelated part. The conveyor part would be used to move the trays into the area, or actually the dishes into the dishwasher. Persons 1, 2, 3, and 4 are also interrelated parts. Clean germs, clean germ-free dishes. This is the output. The dirty dishes, you would have to put those in the dishwasher, so that would be an input. The half-eaten dinner is going to be interrelated part because we hired somebody to scrape that off and throw it away. Sorry about that. Obviously, I was wrong. It's an input. The half-eaten dinner is an input. And so we probably need to think about that for just a second. We're having to place it into the trash can. It has to be disposed of. And I'm not real sure about why they call that an input. To me, that would be more of a process. You just scrape it off and throw it away. The aprons would be considered an interrelated part because that is certainly not an input. You're not putting it into the dishwasher. You're not getting it out as clean dishes. The only one it could be is interrelated parts. And so the only thing that they're trying to get you to do is to think about what inputs are, what the interrelated parts are, and what the outputs are. And the best that I can tell you about that is if you're doing accounting information, you're going to have to input that information into the computer. The computer would be your interrelated part. And then the data that it spits out as far as reports would be your output. And so it's important to understand these categories. In part 3, they want you to select the appropriate items under the following categories to form an operational model or a system for the dishwashing system. An operational model is what we're looking for. So in the first drop down, they're looking for an input. They want to know which one of these is an input. And so we just saw from up above that scraping off food was an input, the half-eaten dinner here. And you see that's wrong. All right, so we need to think about what the input would be. Oh, of course, what is it? You have to have dish detergent to be able to put it into the washer, the dishwasher, so that you can get the output. So I'm sorry, it should be dish detergent here. All right, so I can't get this off of the screen here. That's another one of those Cengage items that's aggravating. So if you'll bear with me for just a minute, I'll put in some more inputs and we'll see if that thing goes away. They're looking for another input here, and water has to be put into the dishwasher for it to work as an input. Water has to be put into the dishwasher so the dishwasher can operate. Another type of input would be electricity. We have to have electricity to operate the dishwasher. Another type of input would be we'd have to put in dirty dishes in order to get them to be cleaned up. And another type of input would be loading the racks. All right, let me try this again. It's an input. Half-eaten dinner would be the input there. You got to put that in the trash, in other words. All right, so I'm going to look at my drop-down list here, and what we're looking for is processes. Processes would be some type of activity. So I'm going to pick loading the racks. And I can't see what I'm doing here for the rest of this. All right, now just click on it and move it out of the way. I've learned something new here today. Processes. We're looking for an activity, such as scraping off the food. Processes are activities, such as washing the dishes. Processes are activities, such as unloading the dishwasher. And then the output would be clean dishes. So technically, we should have done this first. Our input was to put dish detergent in the dishwasher. A process would have been to scrape off the food, and the output would have been clean dishes. But all of these are inputs, all of these are processes, and all of these are outputs. And all of this has to do with terminology, basically, understanding a system and how a system would work. So I'm going to stop here today. And I'll see you next time. Bye-bye.